Welcome to Study Loop.
In this problem on the topic of projectile motion, we are told that in an airplane that is flying horizontally with a given speed, an engine falls off. If we ignore air resistance and we are given the time that it takes for the engine to hit the ground, we want to firstly show that the airplane is 4.5 kilometers high. Next, we want to show that the horizontal distance that the aircraft will cover in this time is 8,400 meters. And finally, we want to know where the engine would be relative to the airplane the moment the engine hits the ground. So firstly, the vertical distance over which the engine falls is y. And we know y is equal to v naught t plus a half gt squared, where v naught is the initial velocity. But the vertical motion is zero, so the initial velocity of the engine as it falls is zero. And so it starts from rest and will fall a distance y of a height of half gt squared, where g is acceleration due to gravity. So this is a half times, we'll use the value 10 meters per square second as an estimate for gravity, times the time over which it falls, 30 seconds, all squared. So if we calculate this, we get this to be 4,500 meters. So the engine falls a vertical distance of 4,500 meters, which we know is 4.5 kilometers as given. So we see that the engine falls 4.5 kilometers since it falls from rest from the airplane in the vertical direction. Now, in part B, we want to show the horizontal distance that the airplane will travel in that time. Now, the horizontal distance, x, is given by the speed in the x direction, which is vx, and multiplied by the time t. Since the horizontal motion is constant if we ignore the air resistance. So the speed is constantly traveling at 1,000 kilometers per hour in the x direction, or in the horizontal direction. So this speed, we're given in meters per second as well, is 280 meters per second, and it takes the engine 30 seconds to fall to the ground, so we'll multiply by the time of 30 seconds. This gives us the horizontal distance that the plane covers in these 30 seconds to be 8,400 meters, again as required. And now lastly, we want to know where the engine would be relative to the plane after the 30 seconds when it hits the ground, assuming that the plane continues to fly as if nothing has happened. Well, remember that the x component of the velocity of the plane is equal to the x component of the velocity of the engine. So the plane and the engine move with the same horizontal velocity, and so the point where the engine strikes the ground, the engine would have been traveling the same speed horizontally for the same time as the plane, and therefore the engine will be directly below the plane.